Hi everyone, and welcome to another video of applications of differentiation. So today we shall be learning about stationary points of a curve. So we'll be learning about the maximum points, minimum points, and the points of inflection. All that in today's video. Let's learn something new. Moving on, we'll look at stationary points of a curve. So stationary or turning point of a curve is the point where the gradient of the curve is 0. So a stationary point can be one of the following. It can be a maximum point, a minimum point, or a point of inflection. So let's look at this curve diagram that we actually have here. So this is a curve diagram that has points that are maximum, points that are minimum, and some points that are points of inflection. So when you look at this, point A is a point of inflection. Then when you look at point B is the maximum point. Look at point C is the minimum point. Point D is again another maximum point. Then you can say that point E is another point of inflection because it is more like point A. And then we can say that point F is the minimum point. So that's what we're going to be doing. And we've said that at those points the gradient of the curve is 0. And then this is the curve y is equal to fx. Alright, so let's look at the maximum points. So a maximum point looks like that. So a maximum point, we can see that we've dotted the point where the gradient is 0 at that black dot. So this thing that dy dx shall actually be equal to 0. And then what happens is when you want that a point is maximum, what happens is when you differentiate it, or when you get the second derivative of that curve at that point, you'll actually find that the second derivative is less than 0. So that's how you know that it is the maximum point. Alright, so let's look at minimum points. So also saying that that is how we represent a minimum point. Then also saying that it's the same thing, gradient is 0, but now when you find the second derivative of that curve, at that point you'll actually find that the second derivative will be a value greater than 0. So that's how you know that point is minimum. Then next to look at points of inflection. So they can look like that on the right or that on the left. So we can also see that their derivative gives us a gradient of 0, and then the second derivative shall actually be equal to 0. So if you differentiate for the second time and the value remains 0, that's how you know it's actually a point of inflection. So we've said points of inflection include points A and point E. Alright, so let's look at some questions to understand this further. So being told to find the coordinates of the turning points on the curve y is equal to x cubed plus 3x squared minus 9x minus 5, and distinguish between them. Alright, so this is the curve that we have here. So when I differentiate it, I get 3x squared plus 6x minus 9. But we know that for turning points, dy dx is 0. So we're going to equate this to 0. So when you do that, first of all, I'm going to divide all sides by 3, and I'll reduce it to x squared plus 2x minus 3 being equal to 0. So when I solve this quadratically, I'll get x as either being equal to 1 or x being equal to negative 3. Alright, so let's look at it when x is equal to 1. So when x is equal to 1, y shall be equal to negative 10. So at that point, this is one of the turning points. So one of the turning points is 1, negative 10. Now let's look at the nature of the turning points 1, negative 10. Alright, so let's first find the second derivative. So as we've said, if the second derivative, the value is less than 0, it's a maximum point. If it's greater than 0, it's a minimum point. And then if it is equal to 0, it is a point of inflection. So now we found the second derivative of this value right here. So we get it as 6x plus 6. So second derivative simply means that we differentiate this for the second time, and we'll have 6x plus 6. But we're not at this point, x is equal to 1. So we have 6 times 1 plus 6, which shall be equal to 12. Now this value is a value greater than 0. So therefore the point 1, negative 10 is the minimum point. Let's look at it when x is negative 3. So we're going to plug that in and we'll get the y value as being equal to 22. Then we have the turning point negative 3, 22. Alright, so let's find the nature of that turning point. So the nature of turning points for negative 3, 22, we find the second derivative. So the second derivative is still 6x plus 6. Now plug in now a negative 3 where you have the x, and then we'll have negative 18 plus 6, which shall give us negative 12. So this value is less than 0. So therefore the point negative 3, 22 is the maximum point. So therefore the point negative 3, 22 is the maximum point. So that's how we find the nature of the points of this curve. Question 2. We're being told to find the coordinates of the stationary points on the curve y is equal to x power 4 plus 2x squared and distinguish, 2x cubed, and distinguish between them. So this is the curve. So we've differentiated it and we have dy dx being equal to 4x cubed plus 6x squared. So we've said that for turning points or stationary points, dy dx is 0. Then equate this to 0. So I can factorize out 2x squared into 2x plus 3. So you can have either 2x squared being equal to 0, so we'll have x being equal to 0, or we can have 2x plus 3 being equal to 0, of which x shall be equal to negative 3 over 2. So when x is 0, y shall be equal to 0. So the turning point is 0, 0. So let's find the nature of this turning point. So first of all, we get the second derivative for this, and we'll have it as 12x squared plus 12x. So when I plug in the 0 where there is x, this is what I have. Then I'll get second derivative, d squared y over dx squared being equal to 0. Now since that value is 0, therefore the point 0, 0 is the point of inflection. And then let's look at it when x is equal to negative 3 over 2. So plug in that for y shall be equal to 81 over 16 minus 27 over 4, which shall be negative 27 over 16. And then let's look at, so we have the, so therefore the turning point is negative 3 over 2, comma negative 27 over 16. So let's find the nature of this turning point. So plug it in the second derivative. So where there is x, I put negative 3 over 2, and I'll get 27 minus 18, which shall give me 9. So this value is greater than 0. So therefore the point negative 3 over negative 27 over 16 is a minimum point. Let's look at the next question. Question 3. Given the curve y is equal to x cubed plus 7x squared minus 24x, find the turning points of the curve and hence distinguish between them. Alright, so this is the curve again. Differentiate it and we'll have 3x squared plus 14x minus 24. So for the turning points, we say dy dx is equal to 0. So equate this to 0, and then we'll get, solve it quadratical, and we'll get x as either being equal to 4 over 3 or x being equal to negative 6. So when x is equal to 4 over 3, we can have y as negative 464 over 27. So therefore the turning point is 4 over 3, comma negative 464 over 27. Alright, so next we can find the nature of this turning point. So plug in the values in the second derivative. So we found the second derivative of dy dx being equal to 6x plus 14. So where there is x, we put in 4 over 3, and we'll get the second derivative as 22. Now we can say this value is greater than 0, so therefore this means that the point 4 over 3, comma negative 464 over 27 is the minimum point. Now when x is equal to negative 6, y shall be equal to 180. Now the turning point is negative 6, comma 180. Now the nature of the turning points for this one is, we're going to plug it in the second derivative. So at this x, we'll put negative 6, and we'll have the second derivative being equal to negative 22. And this value is less than 0. So therefore the point negative 6, comma 180 is the maximum point. Alright, so next we've been told to find the maximum and minimum values of the following functions. So this is slightly different because in this case we're going to be looking for the nature of the different points, and then we're actually going to have to actually investigate them in a way. So investigating is a little bit different when you find maximum and minimum values from what we've been doing at the beginning. But let's see how we do this. So this is the point we have. So first of all, we're going to differentiate this. So when I differentiate this, f prime x shall be equal to 6x squared minus 6x minus 12. So for the turning points, we know that they are actually that the derivative of the turning points, the derivative of fx shall be equal to 0. So we have 6x squared minus 6x minus 12 being equal to 0. Divide every value by 6, and I'll have x squared minus x minus 2 being equal to 0. Now I'll get x either being equal to 2 when I solve quadratically, or x being equal to negative 1. So let's look at the nature of this distribution. So first of all, let's look at it when x is equal to negative 1. So now when we look at the nature of distribution, we actually have to find the nature of the gradient on the left hand side and that on the right hand side. So we need to know how the slope is happening on the left hand side and that on the right. So let's look at for the left hand side value. So what we're going to do is when x is equal to -1, we're going to subtract 0.1 to get the value on the left hand side. So now on this -1 we subtract off 0.1. So when I subtract off 0.1 on this, I'll actually get -1.1. Then I'm going to substitute for the values where there is -1.1. I'm actually going to plug that into this equation. So this becomes our new x. So where there is x, I put -1.1, and in every other place in this equation here, I'll place -1.1. So I'll get 7.26 plus 6.6 minus 12. Alright, so I get 1.86. Now we can see that the value here is actually greater than 0. So therefore, if it's greater than 0, it means we have a positive on the left hand side of -1. Let's look at the right hand side value. Now what we do is we add 0.1 on the right hand side. So -1 plus 0.1 shall give me -0.9. So plug it into the equation of the derivative of the equation, and then this is what I'll have. Then I'll have 4.86 plus 5.4 minus 12, which shall give me -1.74. So I can see that this is actually a value that is less than 0. So if it's less than 0, it means that therefore we have a negative on the right hand side. So that means we have a negative on the right hand side of -1. Now that is it for the value of -1. So let's investigate the other value of x. So now let's look at its left hand side. So on the left hand side, we're again going to subtract off 0.1. So when I subtract 0.1 from 2, I'll get 1.9. So plug in y into the, plug in the value of 1.9 into the derivative of fx, which is going to give me this. Then I'll have 21.66 minus 11.4 minus 12, which shall give me -1.74. So I can see that this value is less than 0. So it means that therefore we have a negative on the left hand side of 2, of x being equal to 2. Let's look at the right hand side value. So on the right hand side, we're going to add 0.1. Then when I add 0.1 to 2, I'll get 2.1. So when I plug in the values, I'll have 26.46 minus 12.6 minus 12, which shall give me 1.86. Now I can see that this value is greater than 0. So therefore we have a positive on the right hand side of 2. So now that I have these and I've found the natures of distribution for both of the x values, I can now put all these in a table. So now I have a table for the value -1 and I have a table for the value 2. So as I can see, on the left hand side of -1, I had positive, and then on the right hand side I had a negative. So where there was 2, where x was equal to 2, on the left hand side we had a negative, and then on the right hand side I had a positive. So therefore this is how we sketch a positive. So a positive is growing towards the right, and then of course a 0 is flat. So where there is 0, it is flat, and then where there is -1, it actually slopes. The slope actually faces down. So therefore we have a maximum at this point. And then next, this is a negative, so it slopes down. So where there is a 0, it's flat, and then where there is a positive, it actually grows like that. So therefore this is a minimum. So we can see that the maximum value of fx, so what happens is this. So this is the general equation of fx that we were given. So as you can see, we can actually now plug in this. So we've seen that there is a maximum in this part. So that actually means that we're actually going to place -1 where there is x. So when I plug that in, I'll have the value being equal to 15. So now I know the maximum value of fx. So next I can find the minimum value of fx. So that means the minimum value is when x is equal to 2. So plug that into the equation and I'll have the answer as -12. So therefore the maximum value is 15 and the minimum value is -12. And those are the answers. So question 5, we're being told to find the maximum and minimum values of the following function. Fx being equal to x cubed minus 3x squared minus 9x. So first of all, let's find the derivative of this. It will be 3x squared minus 6x minus 9. And then we know that for turning points, the derivative of fx shall be equal to 0. So we're going to equate this to 0, divide all sides by 3 to reduce that, and it will become x squared minus 2x minus 3 being equal to 0. Then when I solve this quadratically, I'll get x as being either equal to 3 or x being equal to negative 1. So let's look at the nature of this distribution. So when x is equal to negative 1, now let's find the left hand side value. So we're going to subtract off 0.1. So when I do that, I'll get negative 1.1. Then plug in the values into this equation for the derivative of fx. So when I solve this, I'll have it as 1.3. So this value is greater than 0. So that means that we have a positive on the left hand side. Let's look at its right hand side. So we're going to add the value 0.1. So when I add 0.1 to it, I'll get negative 0.9. So when I plug that into the equation, I'll have it as negative 1.17, which is actually a negative. So actually this value is less than 0. So therefore we have a negative on the right hand side. Let's look at the nature of distribution when x is equal to 3. So for the left hand side value, I'm going to subtract off 0.1. So I have 3 minus 0.1 will give me 2.9. So plug that into the main equation for the derivative of fx. So this is what I'll have. So I'll have negative 1.17, which is a value less than 0. So therefore we have a negative on the left hand side. So therefore that's what we have. Now for the right hand side value, I'm actually going to add 0.1 to 3. So I have 3.1. So put that into the derivative of fx and I'll get 1.23, of which this value is greater than 0. So therefore we have a positive on the right hand side. So when I put this in a table, this is what I have. So there is negative 3. On the left hand side I have a positive, and then on the right hand side I have a negative. And then on the left hand side for 3 I have a negative, and then on the right hand side I have a positive. So a positive is drawn that way, a 0 is flat or horizontal, and then a negative slopes down. So that means we have a maximum where there is negative 1. So now on the left hand side of 3 I have a minimum, 0 is flat, and then that is a positive. So that means we have a minimum point at 3 and a maximum at negative 1. So let's find the maximum value of fx. That means we're actually going to plug in negative 1. So this is the main equation. So plug in negative 1, and what I'll get is positive 5. Then let's find the minimum value of fx. So this is what I have. Plug in 3 to find the minimum value, and I'll get the value as negative 27. So therefore the maximum value is 5 and the minimum value is negative 27. And that's the answer they wanted. Alright, so next we're being told to find the maximum and minimum values of the following function. So the function is fx is equal to x over 1 plus x squared. Alright, so this is what we have. So when we solve this, we're actually going to solve it using quotient rule. So pay attention to that. So when I solve it using quotient rule, I can simplify this further, and I'll have 1 minus x squared over, into bracket, 1 plus x squared squared. Now that I know that, I can now see that for turning points, the derivative of fx shall be equal to 0. So we're going to actually equate this to 0. So when I do that, I'll remain with 1 minus x squared being equal to 0. Because when I cross multiply this denominator will multiply 0 and it will become a 0. Alright, so I can find 1 being equal to x squared, and then when we solve this, so I have 1 being equal to x squared. So when I solve this, I can find that x is either positive or negative 1. So when x is 1 or x is negative 1. So let's find the nature of distribution when x is negative 1. So for the left hand side value, I'm going to subtract off 0.1. So when I do that, this is what I'll get, negative 1.1, and this is what I have. Substitute that into the main equation for the derivative, and then this is what I'll get. So now I have negative 0.21 over 4.8841, which will give me negative 0.043. So you can say this value is less than 0. So it means that therefore we have a negative on the left hand side. Let's look at the right hand side value. So we're going to add 0.1 to negative 1, and I'll have negative 0.9. So put that into that equation for the derivative of fx, and I'll get 0.19 over 3.2761. The answer shall be 0.058, which is a positive. So this is greater than 0. So therefore we have a positive on the right hand side. Let's look at the nature of distribution when x is equal to 1. So subtract 0.1 on the left hand side, and I'll have 0.9. plug that in into the main equation, the derivative of fx, and I'll get 0.058, which is a positive. So this is greater than 0. So therefore we have a positive on its left hand side. And then for the right hand side value, add 0.1, plug it into the main equation, the derivative of fx, and I'll get negative 0.043. So this value is less than 0, so therefore we have a negative on the right hand side. So when I put this on tables, this is what I actually have. So for negative 1, I have a negative on the left hand side and a positive on the right hand side. Then for positive 1, I have a positive on the left hand side and a negative on the right hand side. So this is what we have right now. So we can see that we have a minimum at when value of x is negative 1, and then we have a positive when the value of x is positive 1. So to find the maximum value of fx, I can now use the main equation that was given. So we can say that the maximum value is when x is equal to positive 1. So plug that in. So I'm going to plug in a 1 and I'll get a half. And then to find the minimum value of fx, I'm going to plug in a negative 1 wherever there is x. And then this is what I'll get. I'll get a negative a half. So therefore the maximum value is positive a half and the minimum value is negative a half. And those are the answers they wanted. Alright, so the next question is almost similar. So I've been told to investigate the stationary value of the following function. So it's the same as finding the maximum and minimum values basically. So we have fx being equal to sin x plus cos x. And we've been told that the value of x is in between 0 to pi over 2. So in my language, pi over 2 is like 180 over 2, which is basically 90 degrees. So it basically would mean that the value of x should not be greater than 90 degrees. So let's solve this. So this is what we have. So when I differentiate this, I'll get cos x minus sin x. Now we know that for turning points, the derivative of fx shall be equal to 0. So equate this to 0 and I have sin x being equal to cos x. So this can be made sin x over cos x being equal to 1, of which I have tan x being equal to 1. And then x shall be equal to tan inverse of 1, which shall give me 45 degrees centigrade. And we know that 45 is the same as pi over 4. Let's find the nature of this distribution. So when x is 45 degrees, for the left hand side I'm going to subtract off 0.1. 45 minus 0.1 shall give me 44.9. So plug that in and I'll get 0.70834 minus 0.70587, of which at the end I'll have 0.002. So I can see that this value is greater than 0. So therefore we have a positive on the left hand side. So for the right hand side value, I'm going to add 0.1. That's why I have 45.1. So plug that in into the equation of the derivative of fx. This is what I have. So cos 45.1 will be 0.706. Sin 45.1 will be 0.708. So when I solve this, I'll have negative 0.002. So when I plug that in, I can see that therefore we have a negative on the right hand side. Now since the only value of x was 45 degrees, so it means that this was only that we had to do. So when I draw this on a table, I can set I have a positive on the left hand side and I have a negative on the right hand side. So therefore this is how it will look. So this is actually a maximum point. So we have a maximum when x is 45 degrees. So now we can only find the maximum value in this case. So maximum value of fx, we should actually have it as being equal to this. So where there is x, I'm going to plug in 45 degrees. So sin 45 is root 2 over 2, and then cos 45 is also root 2 over 2. So when I add this, I'll have 2 root 2 over 2. So therefore, I can see that this 2 and this 2 cancel and I'll be left with root 2. So therefore, the maximum value is root of 2, and that is the answer. Right, so next question is question 8. We're being told to investigate the stationary values of the function y is equal to x power 4 minus 4x squared. So this is the function. So when I differentiate this, I'll get 4x cubed minus 12x squared. So remember, we're also investigating the stationary value. So it means that we should actually also draw the tables and investigate for the value on the left hand side and the value on the right hand side. So for turning points, dy dx is equal to 0. So equate this to 0, and this is what I'll have. Now in this case, I can say I have to factorize out 4x squared into x minus 3 and equate that to 0. So either 4x squared is equal to 0, of which x shall be equal to 0, or x minus 3 is equal to 0, of which x shall be equal to 3. Alright, so let's look at the natures of distribution. So when x is equal to 0, Let's look at the left hand side. So on the left hand side, I'm going to subtract off 0.1 to get that value on the left hand side. Now 0 minus 0.1 shall give me negative 0.1. So now the derivative in this case is actually this function here, 4x squared minus 12x squared. So it's actually where we're going to be substituting in. So when f is negative 0.1, I'll actually substitute it into this equation. So I'll have it this way. So I'll get negative 0.124. So its value is less than 0. So it means that therefore we have a negative on the left hand side. So let's look at its right hand side value. So I'm going to add 0.1 to the 0 and I'll have 0.1. So this is what I have. So I'll have it as negative 0.116. So therefore this value is also less than 0. So therefore we have a negative again on the right hand side. Let's look at the nature of distribution when x is 3. So for the left hand side value, we're going to subtract 0.1 from 3, which shall give me 2.9. So plug that in into the function, and this is what I have. I have negative 3.364. So this value is less than 0, so therefore we have a negative on the left hand side. Let's look at its right hand side value. So add 0.1, and then I'll have 3.1. So plug in that, and I'll have 3.844, and this value is greater than 0. So therefore we have a positive on the right hand side. So now that I know that, I can now draw the tables. So now for 0, I can see that it was negative on the left and negative on the right. And then when x was 3, I had a negative on the left and a positive on the right. So therefore, on the left hand side, when x is equal to 0, I have a negative and a negative. So that's what I have. So it shall be a point of inflection. And then when x is 3, I have a negative and a positive. So it shall be a minimum point. So let's find the inflection point. So inflection point will be that. So I'm actually going to plug in a 0, 0, and then I'll get a 0. And then to find the minimum value, I'm actually going to plug a 3 into the main function, and I'll get negative 27. So therefore the inflection point is 0, and the minimum value is negative 27, and that is the answer. Question 9, we're being told to investigate the stationary values of the function y is equal to 3x to the power 4 plus 16x cubed plus 24x squared plus 3. Right, so this is the function. So when I differentiate it, I get 12x cubed plus 48x squared plus 48x. So remember, for turning points, dy dx is equal to 0. So in this case, I can factorize out 12x and have 12x times x squared plus 4x plus 4 being equal to 0. So either 12x is equal to 0 and x shall be equal to 0, or x squared plus 4x plus 4 is equal to 0, of which I can get, when I solve this quadratically, x can be equal to 1 or x can be equal to negative 2. Alright, so in this case, we have 3 values of x. So let's look at the nature of distribution when x is 0. So for the left hand side, we're going to subtract off 0.1. 0 minus 0.1 will give me negative 0.1. So this is the function that we shall be using, because this is the derivative, the first derivative of y. So this is what we have right now. So plug in negative 0.1 in, and I'll get negative 4.332. So this value is less than 0. So therefore we have a negative on the left hand side. Let's look at its right hand side value, and we're going to add 0.1, and then this is what I'll have. I'll have 5.292, and this value is greater than 0. So therefore we have a positive on the right hand side. Let's look at the nature of distribution when x is equal to negative 2. So left hand side value, I'm going to subtract off 0.1. Then this is what I'll have. I'll get negative 0.252, which is the value less than 0. And then we can say that we have a negative on the left hand side. Let's look at its right hand side value at 0.1. So what I'll have is negative 0.228. Now this value is less than 0. So therefore we have a negative on the right hand side. Let's look at the nature of distribution when x is equal to 1. So for the left hand side value, I'm going to subtract off 0.1. Now 1 minus 0.1 will give me 0.9. So when I plug those in, I'll get 90.828, of which this value is greater than 0. So therefore we have a positive on the left hand side. Now for the right hand side value, I'm going to add 0.1. So I have 1.1. So plug that in, and I have 126.852. So this value is greater than 0. So therefore we have a positive on its right hand side. So when I put all these 3 in tables, this is what I have for. So for the negative 2, I had a negative on the left and the positive on the, and a negative on the right. So for this x is 0, I have a negative on the left and a positive on the right. So when x is 1, I have a positive on the left and a positive on the right. So now this is what I have. So as you can see, this is a negative, then this is a point of inflection, and then here I have a negative to positive, so this is a minimum point, and then next I have a positive to a positive, so that's also a point of inflection. But now the points of inflections are slightly different. Alright, so now I have a concave down inflection point and then a concave up inflection point. So for the concave downward inflection point, where we have -2, this is what I have. So I'll have it as positive 19. And then let's look at the minimum value when x is 0. Substitute that into the main equation and I will get fx being equal to 3. And then let's look at the concave upward inflection point. So this is what I have. So that is 46. So these are the values at the different stationary points. So this video continues on into the next video of curve sketching of polynomials, and then there will be an exercise at the end of it that I'll encourage you to try out later. So there will be a part 2 to this, but thank you so much for watching. Thank you so much for watching this video. I hope the video really helped you. If it did, feel free to share the video with all your friends and help as many as you can. And then if you really like the video, feel free to give the video a like or a thumbs up, and then tell me in the comments if the video really helped you, and I'll try to get time and reply to your comments. And then if you're new to this channel, I encourage you to join the community by subscribing, and then make sure to hit the notification bell so that you get updated every single time I upload a new video. Thank you so much for watching, and I'll see you in my next video.